Alright, when it comes to calculating molar mass, this shouldn't be all that difficult. Here we have three carbon atoms at 12.01 each. That multiplies to make 36.03. We have 8 hydrogen atoms at 1.01 grams per mole each. That gives us 808 grams per mole for a total of 44.11 grams per mole. In question number 2, we have 1 aluminum atom. We have 3 nitrogen atoms, and of course we have 3 times 3, that's 9 oxygen atoms. And when we calculate those out, we get those numbers there for a grand total of 213.01 grams per mole. Okay, in this question here, we need to calculate the number of molecules, or pardon me, the number of moles in a sample of water that has 3.6 times 10 to the 26 molecules. If we're trying to calculate the number of moles, we know that we need to divide by the Avogadro's number. So there we have the division. We run the division through our calculator and we end up with 598 moles. And of course our molecules cancel out. We end up with moles in the denominator of the denominator, which puts it in the numerator. And in this question here, we need to figure out the number of moles again. So we have our molar volume and we have our volume. To figure out the number of moles, we're going to divide by the molar volume. So we have 0.159 liters, and we divide it by 22.4 liters for each and every mole. Run that through our calculator, and we end up with 7.10 times 10 to the minus 3 moles. Now check your rounding on that. Your calculator would have said 7.09. I think it was 8, but of course that rounds to 7.10. And now we're going to figure out the number of moles of ammonia in 5.20 grams of ammonia. And we've already calculated the molar mass at 17.04 grams per mole. So we take our 5.20 grams and we divide it by 17.04 grams per mole. And we end up with an answer of 0.305 moles.